Welcome to Cactus 2. In this tutorial, we examine the memory visualization of Cactus 2. The Memory Designer is a view of the memory structure of a hardware design. It uses the path search algorithms of Cactus 2 to inspect all of the routes from every initiator bus interface. A valid path ends in a target bus interface containing a memory map. This route is then examined and every address change in all of the bus interfaces is taken into account and constructed into a full view of the memory structure. The Memory Designer can be opened from the toolbar of a hardware design editor, or from the context menu of the selected hardware design item in the library. The Memory Designer is separated into columns, with specific columns for address spaces and memory maps. Toolbar contains a separate section for displaying the data given by the Memory Designer. These buttons filter the sub-items of the main memory items. When an item is made visible, the Memory Designer places them inside their parent item. Unconnected memory items start out as hidden, but can be displayed in the Memory Designer. Additional memory items located between the starting and end points of the path can also be made visible. The base and last address of a memory item are displayed at the top and bottom of the item. These are modified by the address changes made in the interconnections of the attached bus interfaces in the hardware design. The tooltip displays the identifying information of the item, as well as the generic base and last addresses. The component editor can be used to further examine and edit the address of a memory item. The Memory Designer provides a quick access to the component editor through the right-click context menu. The size of the address space item does not match the size presented in here. This is because the Memory Designer takes into account all the variables in the hardware design editor when constructing the items. The parameters of the component instance of this component change the value for the memory size, thus changing the size of the memory item in the memory design constructed from this hardware design. The calculation of the memory addresses of the connected items begins by locating the bus interface parameters from the path. The first memory item is the address space attached to the starting bus interface. The address of the next memory item is modified by the address changes made in the previous bus interfaces. An address change is the base address values of the initiator interfaces in the path, combined with the remap address values of the mirrored target interfaces. We can figure out the position for the last memory items by calculating the address changes along the path. If we compare this to the simplified version of the same design, it can be seen that the connected memory items are located in the same addresses. The range of the memory connection is primarily determined by the size of the connected memory item. In a basic connection, the full range of the memory item is used. If the connection is made through a mirrored target interface, it is possible to specify a desired range for the connection. If the range is greater than the memory item is extended to display the full connection. Changes made to the memory items are reflected in the Memory Designer. Let's edit the base address of a single memory map to demonstrate this. These parameters govern the address values of the mirrored target interfaces in component Wishbone bus, and thus determine the positions of the connected memory items. If the base address of receiver 0 is changed, the storage memory map connected to the Wishbone receiver bus interface of component external memory large is moved. In order for the Memory Designer to display the changes, the edited document must first be saved. After that, the Memory Designer itself is refreshed to display the new position. A base address value of 0 is depicted as the memory map being at the same level as its connected address space. If the base address of receiver 0 is changed to make the connected storage memory map overlap another memory map, Cactus 2 displays the overlapping areas of the connection in red. This marker can be disabled using the button on the Memory Designer toolbar. The Memory Designer helps in defining the memory structure of a hardware design. Here we can observe more complex memory structures. The Memory Designer allows the user to observe the current memory connections in the design, spot any irregularities, and make any adjustments necessary. Thank you for watching this video. For more information on Cactus 2, please see the other tutorials, or visit our GitHub page.